Good day. In this part, we want to talk about tree diagrams. So tree diagrams work as a visual aid that help us see probabilities of events, and we will be representing a common site, which is a tree. A tree has branches and the branches join. So probabilities of branches that join add up to 1. So you'll be having events and most probably they are complements. And then you can further extend the branches in the same way that a branch can subdivide into further smaller branch along the way. So let's take a look at this example. So in a restaurant, 40% of the customers choose steak for their main course. If a customer chooses steak, the probability that he will choose ice cream to follow is 0.6. If he does not have steak, the probability that he will choose ice cream is 0.3. Find the probability that a custom picked at random will choose A, steak and ice cream, or B, will choose ice cream. So let's identify the events in this case. So here we have the event of choosing a steak. So that's what starts. So you lead with the events that start. So here we are talking about the steak. So say that the customer can choose the steak or not choose the steak. So we have our tree starting from, you can think of it as the root. These are the first two branches, or maybe the main trunk. These are the first two main events. Choosing steak, not choosing the steak. This will be the complement. And the probability of choosing the steak, remember, was 0.4. So the probability, right, of not choosing the steak would be 0.6. So after choosing the steak, we are talking about ice cream. So if a customer chooses steak, the probability that he will choose ice cream to follow is 0.6. So if it is ice cream, then I prime will be not choosing the ice cream. So the same will also happen if the customer does not choose steak initially. So these are our events, right? Not choosing this. So we said if a customer chooses a steak, so chooses the steak, this is the path. The probability that you will choose ice cream to follow is 0.6. So choosing ice cream will be 0.6 there. And then here it will be 0.4. Now take a look, that 0.6 plus 0.4 still adds up to 1. Like what we said, that on the probabilities on connected branches add up to 1. And then we are also told that if he does not have steak, the probability that he will choose ice cream will be 0.3. So we have our 0.3 here, and then from 1, 0.3 from 1, we have 0.7. So this is our tree diagram. It's complete now. So now we can use it with ease to find the probabilities. So what is the probability that a customer picked at random will choose the steak and ice cream? So how does that work? It's pretty straightforward. So we go with A. So we are choosing steak and ice cream. So that is the part. So we can write probability of choosing steak and ice cream. That's going to be for steak, choosing steak 0.4, and then choosing ice cream after choosing steak, that's 0.6. So and. So you multiply those two, you should get 0.24. For part B, so now it's easy from here because we now can see all the probabilities for all combination of events. What is the probability that a randomly chosen customer will choose an ice cream? So the customer will choose an ice cream after choosing steak or after not choosing the steak. So the probability that a customer will choose ice cream will come from the customer choosing steak and ice cream, or remember, or is plus, right? Or they don't choose the steak, then they choose the ice cream. So all these events, all these combinations of the events will lead to the customer choosing ice cream. So for the steak and ice cream, we have the 0.24 is above, right? And then plus not choosing steak and choosing ice cream, that's actually 0.6 times 0.3. So you punch that in the calculator, you're going to say the 0.24 plus 0.6 times 0.3. So you should get your answer there as 0.42. Now that's it. That's how we deal with problems that involve tree diagrams. Thank you.